Hello everybody, thank you for joining me today. My name is Alex Dima. I'm a senior software engineer on the Visual Studio Code team at Microsoft. We are working out of Zurich, and today I would like to tell you a little bit about some of the lessons we've learned while developing and shipping Visual Studio Code. And I will try to give some insights into what we've been doing, into what we've learned, and hopefully this would also help you in what you're doing as well. Yeah, first a reminder to rate the talk. So this is basically Visual Studio Code. I'm sorry if you cannot really see it that well. This is what we ship every month, and I hope you know actually quite a lot about it from Eric's talk earlier. In reality, we actually ship two different things. So we ship Visual Studio Code, which is more or less a web app. So it's an app built using JavaScript, built using Node.js API, and built on top of a browser API. And they all come in the shape of Electron. Electron basically consisting of a merger between Chromium and Node.js. But at the same time, we ship a library, which we call the Monaco editor, which more or less contains the thing in red over there. We take that thing out of our product, and we ship it separately as a JavaScript library that can run in any modern web browser. So if you have an app where you're showing code, you can actually even today go on NPM and fetch the Monaco editor node module. I'm still working on the documentation, so it's still a work in progress, but yeah. So that's what we do today, but we didn't start doing that, and we actually started since quite a number of years, actually since the autumn of 2011. And back at the time, as Eric mentioned, we were given the mission to redefine and create developer experience or development tools that work in the browser. So at the time, we actually started in JavaScript. Our patterns were consisting more or less of trying to create classes, where in JavaScript you would use prototypical inheritance and so on. So we would literally say function my class.prototype.foo equals something. So we would all write idiomatic JavaScript to try to create some sort of classes and patterns and types in our source code. One thing we got right from the beginning is that we jumped straight on promises as a way to abstract away asynchronicity, right? So whenever we built something in the UI, whenever we had to compute something, so for example, you move your mouse over a piece of text, and we have to show you a hover. So whenever we do that, we build the UI code in such a way that in the end, the UI code makes a call, and that call returns a promise with the actual thing to show. So this was actually a big win for us, because whenever we changed architectures, whenever we moved away from running only in the browser to running in this Electron environment, we could just substitute the implementation of the hover providers, and instead of executing them in a web worker, all of a sudden we could just spawn a process and do it in a separate process, and we had literally 0 changes to our UI code. So I was actually, from the beginning, I'm a hardcore JavaScript programmer, so I actually love JavaScript. And any project I start, I immediately start in JavaScript. But at the same time we were starting at Microsoft, what became to be the TypeScript compiler, this little team, they also started something. They called it at the time, they called it Strada. And it was still an experiment as far as they were concerned. And they were also looking for early adopters of their compiler. I was a big skeptic, so actually I tried to stay away from it for as long as I could. But then at one point, I actually understood their promise, which is that of basically giving you the necessary tooling to be able to write and maintain a large application that at the end of the day executes in JavaScript. JavaScript, as far as I'm concerned, and you guys know as well, actually fulfills the promise made by Java, if you would like. You really write your code once, and it really executes everywhere. However, if you keep on adding people to a team, or if your code is growing and growing, and you have multiple pieces that you need to stitch together, at one point, you're going to be a little bit scared to make changes. So I personally wrote lots and lots of tests to cover my code, but then every now and then I would need to change something in someone else's. Like I just need, oh yeah, they're calling me in a weird way, let me fix it up a little bit. And every time I would do this, I would get a little bit nervous because I was never really confident that the changes I do are really going to work in the end. So that's actually one of the things that TypeScript tries to help with, which is it's actually trying to give you an extra layer of security. More specifically, it protects you against your own stupid. So how should I say this? It's more like a safety net. I see it as a safety net and as a set of tools that allow me to be more productive. TypeScript, unlike many other languages, does eventually compile down to JavaScript, but it is a superset of JavaScript. So what does that mean? That means that any JavaScript you can write is actually TypeScript as well. So TypeScript just adds some optional syntactical constructs, such as type annotations and interfaces, and generally makes authoring JavaScript code more pleasant. All of these things, they mostly come only with benefits, as they allow you to have rich tooling at compile time. And all the TypeScript, at the end of the day, compiles down to JavaScript. So at runtime, there's zero cost associated with writing your code in TypeScript. OK, so I would introduce a little bit how TypeScript works. And I hope you get to see my screen. So here I will just launch Visual Code over a simple folder, which contains just a single file. I hope you can read it. And this one simply contains a method that sorts an array. And for each member of the array, it does a compare on that array name. Now, as I said, any JavaScript is a TypeScript. So if I just go ahead and rename this .js to .ts, besides the thing in the corner here that tells me that this is now TypeScript, nothing really has changed, right? Because this is all valid TypeScript. However, you see at this point that if you just keep only the JavaScript subset of the TypeScript language, you don't really get a lot out of it, right? So TypeScript is good, and they know that there's a method sort by name, and they know that it takes an argument, but they have no clue what this method is supposed to take and what this method is supposed to return. So I can just pass in 5, and they will be happy with it. Now, the true value of TypeScript comes in once you begin a little bit to decorate your code with a little bit of explanations, which would also help you in the future. So, for example, I have here a snippet that actually the sort by name function is supposed to take an array of person, right? So I will just add it over here. And all of a sudden, not only did I communicate this to myself in the future or my teammates that this function should be called with an array of persons, but all of a sudden you see TypeScript lighting up, and it's already beginning to show us some problems with our code, right? Which otherwise, as far as we were concerned, looked perfectly reasonable, and it would just fail at runtime. Now, what's interesting about this is that you don't have to pollute your code and write at each and every location the type of your variables. So, for example, result is inferred to be a person array. You don't need to say it again, oh, result is a person array. Or basically here, x and y, when you call sort, they already know that x and y should be a person, so you don't need to do anything there either. So all of a sudden, you get all this rich typing only by just more or less explaining what the arguments passed in. Even better, they already know what your function returns, which is given a person array, it returns a person array. Now, this is basically the keeping safe from stupid. Like you would just run the compiler and it has errors, so you would not ship your code. But the true power of TypeScript comes in when you want to work, right? So when you would just type now, they already know that X has a member called name, and name is a string, so I can do locale compare, and I can compare it with y.name. So if you do this from the beginning, this mistake wouldn't even have happened because you would just autocomplete locale compare, and it's not locale compare, right? It's just a typo. So I can fix this, and now it's happy. Of course, it's not entirely happy as I give it a 5, so I can, for example, give it an empty array. And yeah, basically, this looks a lot better. Now what we can do is we can try to generate, I mean, so far, all you've seen, all these squiggles, they were just inside the editor, right? Nothing was really happening. You still cannot see the result of your work. But if you just, for example, run the TypeScript compiler, and I will just launch it to watch this file, it will automatically generate next to this TS file the JavaScript file, right? And as I said before, this is 100% your code. The only thing that happens is that these type annotations are dropped. So there's no more person array. Also, the interface we use to describe this just disappears, as JavaScript does not have such a construct. Now, the nice thing about this is that you can use, for example, constructs which maybe not all JavaScript runtimes have. So if I now use a lambda function here, TypeScript will down-level compile it to a normal function. So you can make your code nice and beautiful and use new ECMAScript 6 or maybe ECMAScript 7 already features, and still down-level compile it to run in any environment that JavaScript runs in. Another interesting thing, which I said about it, so let me, for example, in here, create something. Now, as you see, when I do control space, they know I'm supposed to give in an age because a person has to have an age according to my definition of it. Let me make this even more complicated. So this is just, for example, how a class gets down-level compiled, right? So since ECMAScript 5, it only came out in ECMAScript 6 that you can actually use the class syntax in JavaScript. They down-level compile it to the idiomatic JavaScript you would have written by making function greeter.prototype.greet, and so on. Something which is very important to recognize, and here let me just stage these files that you get to see the diff, is that right now I can just, for example, go on this name, and I can just say right-click rename. I can call it full name. And all of a sudden, TypeScript knows to change exactly the locations it must. So if you look at the diff, it basically left alone this name over here because it knew that this name is not having anything to do with the interface person or with the rest of the code, right? So it's pretty cool that you can now make a refactoring in your code and have the confidence that your code is still executing the correct way. One last thing I wanted to show you on this sample is, so if I now run tsc -init, this basically creates a tsconfig.json file, and more or less this contains instructions for the compiler, right? It tells it the module system I'm using for my code is CommonJS, and it says exclude some folders from it, which in this case they don't really matter. But now if I run the watch, I can, for example, say, oh, look, I know for a fact that I'm not targeting any ECMAScript 5, right? I know for a fact I'm not just targeting any browser. I know I'm targeting Node version 6 and up. So I can just say Node version 6 supports ECMAScript 6. I can just change this to a 6. And what will happen is that, oh, sorry, I mistyped. Let me do it again. Is that now they generate the code by keeping the native syntax that ECMAScript 6 brings in. So now they do use a class when you write it because Node actually supports it starting version 6. They do use Lambda functions and so on. So all the time your code can be nice and can be already up to the latest ECMAScript spec, and you can still have it run in any environment you have. Now let me close this for a second and maybe show you something a little bit more interesting. Here I also have the same sort of idea. I mean, the idea behind it is the same. Okay. Let me just try to wake this guy up. Is it more happy now? Yeah, okay, that looks more happy. So, for example, here this code is using destructuring, right? So there's a function called point that it gets passed in 2 numbers. This is new ECMAScript 6 syntax that you can just create a literal. So that actually means what you see here on the right. And you can also use destructuring to extract the individual properties of an object, and TypeScript also down-level compiles that for you. To actually run it, I have to do the same. It should result in the same diff. Now what's interesting and what TypeScript already supports is basically async and await. So if you do use promises, you can now write your code a lot nicer. So the idea behind this example is that there's a function called delay, and that returns a new promise. I'll get in a second to why the squiggles are there. This one returns a new promise, and this promise would just resolve itself after a number of milliseconds. Now what's nice about this is that, for example, the function ping inside a loop calls 10 times the delay and waits each time for this delay to occur. And after each of those, it basically logs a ping. And then the function main is just awaiting the whole thing to happen. Now the squiggles you get here are because of a missing feature that TypeScript has on the roadmap. So right now, they cannot down-level compile async and await to ECMAScript 5. Because if you look at the generated code, so let me fix it and let it know that I am, in fact, targeting ECMAScript 6. So now the errors should go away eventually. OK, there they go. So the reason they cannot down-level compile yet to ECMAScript 5 is because they actually use generator functions behind the scenes together with the new yield keyword to implement this behavior and leave your code more or less top-down, right? You write it top-down. They have to mangle it a little bit, so they wrap it inside a helper called the waiter, but at the end of the day, your code stays the same way you wrote it. OK, so that's that. I hope that was a really brief introduction to TypeScript. So, OK. Now, one of the things which we did not get right from the beginning were basically dependencies. So we utterly failed to keep track of what each JavaScript file needs and what it provides, right? So that's the basic rule. If you want to have a good system, you should have a way to know what each of your file needs to run correctly and what it can offer to anyone else built on top of it. And we totally sucked, and we totally failed at this at the beginning. And one of the reasons for that is because we were using namespaces, right? So we were using, namespaces being a very fancy word for globals. So, for example, in a certain file, we would just reach on to this, I call it namespace.util.strings, and define a new method on this namespace. However, the problem here is that there's no correlation between the file that actually does this and the namespace that's actually being defined, right? So here I could call the file strings.js. I could call the file utils.js, but the problem is that nobody in my team would know where to actually find the implementation of the trim function, right? They might be using it everywhere, but they wouldn't necessarily know, unless you're really careful about it, they wouldn't necessarily know which file on disk they should go open and change such that they can change this method. So renaming files was a huge pain. Renaming namespaces was something we never did because we wouldn't know where they are all used. And of course, if you just try to do a string search, as you saw before with the name case, right? You would just hit so many different locations. You wouldn't know which one is a false positive or not. So yeah, I guess this is a fun way to depict what I think was our dependency graph at the time. But regardless, so back then we had our source split up into client and server. So we would have this tiny little Node.js server that would serve up all the contents, and it would know how to read files from disk, write files to disk, and so on. But most of the code was client-side. So most of the code was running inside the browser. Now for Node.js, it is a given, right? Everybody that does Node.js uses CommonJS as a module system. And this is great. I mean, it's great that Node came out with something like this from the beginning. However, there is a little subtle catch which many people are not aware of. So, for example, how do you think Node evaluates this code that you've written, right? So what they do is when they load up my module.js, is they will more or less read this file from disk. Yeah, they do a little bit of wrapping where they add a dir name and so on. But then they will go on and evaluate it. And as part of evaluation, you see the problematic line over here is that they basically have to make an implementation of this require function. And if you step in and keep on stepping, like until you really reach the meat of this require, you will see at the end of the day, it does an fs read file sync or equivalent, right? So it will literally block the VM execution. The JavaScript VM will be blocked until it goes to disk and tries to read this file out. And why does it do that? Because that's how the code is written, right? So the code at this point, when this require function returns, it should very well return whatever is exported from that other file. So CommonJS is great because you get to tell exactly in a file, this is what I need, and this is what I give to you in the form of the exports. But basically, the problem with it is that it's very suitable for running on a server, maybe, where you have local disk access, right? You cannot do this in a browser. You cannot expect to ship this code up and then in here do basically a synchronous XHR request to try to fetch your dependency. So that's basically at the time when we looked into it. That's also when AMD came out. So AMD stands for asynchronous module definition. And the only real difference in the code is that it's all the dependencies of the actual code are in a way extracted outside in an array. So what this means is when you actually look at and run this code, you can capture, yeah, this is the code I need to execute inside this function, and these are the dependencies I need to fulfill before executing that code. So basically, if you write a loader like that, you can then asynchronously fetch this dependency ID, and once you have that, and once you have resolved that, that's when you can actually run the actual code. So we actually stuck up with AMD, and I will give some more examples why we find that useful. So this is from a time when there was no other module system, right? There was CommonJS and basically AMD. Okay, so yeah, before that, the good thing about TypeScript is that it actually supports that you can compile your JavaScript to either one of the two, or even something they call UMD, Universal Module Definitions. So in TypeScript, you just use the new format for dependency that will come up in ECMAScript 7, I think. So you just write your code normally. There's no spaghetti. There's no define function. There's no nastiness. And then you just, by the flick of an option, as I showed you there in the tsconfig.json, you make it compile, and it generates CommonJS looking code or AMD looking code. One of the advantages of AMD, which we began to benefit from early on, is the lazy code loading. So one of the things we do is, for example, if you open us up and we ship with like 30 languages, right? We have PHP, C#, I don't even know them, Ruby, and so on. Like there's just so many of them. And you know what would be really, really stupid is that if you would open a TXT file, all of a sudden you will load those 30 languages just because they're there, and try to start them up just in case they're needed. So what we're actually doing is we split our code up, or we have a sort of like a contribution system where on the one hand, something which is mostly like, I don't know, 30 bytes or whatever, when you minify it and so on, this just describes to the system that there is a language called PHP which should kick in once you open a PHP file or a PHP 4 file or a PHP 5 file. And once you do that, once you actually do open it, then you should load the module at blah, 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 and instantiate the class called blah, blah. So basically, when you open a text file, the only thing that is loaded is this piece over here. And then only later, when you open a PHP file, does the entire PHP thing get loaded. And this, yeah, okay, sorry. So it might look that it's smaller, but in fact, this is lots of code over there to actually implement PHP and all the semantics and all the coloring and so on. Yeah. So yeah, we like to think of it like an iceberg, right? Like we have a little part which gets synchronously loaded that describes that the other part should kick in at one point or another. And then hopefully the large piece of code that actually knows how to do PHP is only lazily loaded, for example. Another thing which we do is we take advantage of AMD loader plugins. So whenever we write our code, by now it's all done in TypeScript, we can just have besides the regular dependencies, we can just write a dependency to the CSS that this file needs. So for example, this is just like I just took some lines from the code that renders the current line highlight. So when you move around in the editor, we render a little highlight of the current line. Now, how this highlight works is that in the end of the day, it creates a DOM node, and it sets a certain class name on this DOM node, and then it maintains it, right? If you move your cursor up and down, it moves up and down. But essentially, it's just a DOM node with a class name. And of course, to make things nice, you want to put the styling of your app outside of the JavaScript or TypeScript code, so you put it in a CSS file. So now, whenever we end up loading this file called currentLineHighlight.ts, this dependency will show up. We will actually invoke the AMD CSS plugin, and which is indicated by this bang over here. So we will load first the plugin called VSCSS, and then pass to it as an argument the rest of the thing. And the rest of the thing is more or less the path to how to find the CSS file. So we actually make use of this both at development time when you want to run something, and we also make use of it when we bundle. So that's one thing we do, and we are actually keep on doing since a very long time. And if you want to take away something with you today, is maybe you should really look into bundling and minifying your code, even if it runs on the server side, which sounds so stupid, but it's true. So, for example, this is the startup time of Visual Studio Code. This is split up into 3. So the first piece is basically just a given. That's just Electron. It takes a little while to start up. It needs to load 40 megabytes of goodness. We love that. We want to have all the APIs of HTML5. We want to have all the APIs of Node. It's what it is, right? It's a given cost start. It's basically the same cost that you would when you open Chrome, for example. There is a certain cost until JavaScript finally kicks in. The one at the end is just logic. It's just some code which renders the first time things start up. And the thing in the middle is the actual time spent in loading and evaluating the code. The first one is when we run with maybe 1,000 different files. So this is all locally, right? Everybody says you should bundle in Minify because each byte you send over the wire costs. Each request you make to the server has a certain latency, and you should try to minimize those. But this is all running locally. It's all running off of my SSD. So what I found very interesting is that simply by bundling all the files into one, you actually get quite a benefit. So this is all the same code. You end up shipping the same thing. You don't even change anything in your code. It's just a matter of how you package it. And then we thought, oh yeah, let's just put it all in one bundle and not minify it. Why minify it, right? Maybe people wanted to edit it and look and debug it and so on. But then even minifying helps. And I left it here as a link at the end, as a hint. I don't know if you knew this, but for example, V8, if you have a function, you know, like at one point you can go on a function and say function.toString, right? And this shows you more or less the body of the function. Now, if the body of the function is over 600 characters, that function will never get inlined anywhere, regardless how many times you call it, and like maybe you have a big fat loop of going to 10 million and you call a single function that adds 2 numbers, that function will never get inlined if it's over 600 characters in size. It's just a number. The V8 guys came up with it, and they ship with it, and they don't care. But basically, if you minify your code, and it sounds so stupid, right? Just minify your code. It will more or less extract the comments. It will make all the identifiers smaller. And you might have a very good chance that all of a sudden, a function which was not inline before is now inline. So, yeah. Yeah, after we finished and after we actually moved all our code to AMD, we were very happy about it. Okay, so this is more or less the basics, right? Like we finally, after a while, we figured out the basics, which is like, yeah, manage your dependency, duh, of course. I don't know, use good abstractions like promises and classes and so on, of course. And at one point, our code just kept on growing and growing. I mean, you'll notice in the end, I don't even know, because at this point, we're split into so many repositories that I don't even know. I just gave up. I didn't have I didn't feel like writing a script that goes and pulls sources from different repos and tries to eliminate the tests and so on to figure that out. So as we kept on growing, I actually gave up my huge anti-TypeScript opinions. And the reason for that, so this is actually a funny story. So I don't know if you were paying attention in Eric's talk this morning, but we basically now ship with Internet Explorer, starting with IE 11 and what they now call Edge. So when you do F12, if you've ever have to done that, you can debug your JavaScript in there, right? So that's actually our component. And one of the things they asked for is that people, when they do that, sometimes people, they end up maybe stepping by accident inside jQuery.min, right? Now, jQuery.min is not the worst file, but it's a file that contains everything on the first line, right? So we were like, yeah, just take our code. Our code is awesome. The first thing they tried, it failed miserably. And then I was going home crying. No, but basically what I realized is I had all of a sudden between my view code and between my model code. So the editor is split up into sort of like a view model controller sort of thing, where in the model, which keeps the buffer, I just have like an array of lines. And in this case, for jQuery min, I had an array of 1 line. It was just like a very long string. And I realized I actually all of a sudden needed to plug in something in between the view and the model, right? I needed to plug in what is now in the source, and it's called the view model. And now what this view model does is it basically transforms the model and splits this huge 1 line into multiple lines, which, okay, so in plain people talk is called word wrapping. So I was just building it up, right? But it's more or less when you have a long line, right? And you've seen this in all the editors you use. At one point, the code will wrap if you want it to, right? Or it could wrap at the level of the viewport, or it basically maybe wraps after a certain number, and so on. But basically, I had to introduce all of a sudden in all this view code, which was already like tinkered and optimized, I had to completely replace the data structures, that it no longer goes to the model, but it goes through a view model which has the chance to do something with the actual text to make things better. So instead of spending 3 weeks doing that, I spent 3 weeks going to TypeScript and more or less 2-3 days doing that. Because it was a lot easier once I was converting my code to TypeScript. It was a lot easier to see what sort of data structures my view needs, and then I would just implement them and provide them through this view model. Yeah, I think this is my speed. I don't know if this is really important, like, yeah. And, well, okay, we also have some team-specific rules. So, for example, we try to put return types, like as I showed earlier, that TypeScript can guess it. But at one point, you're actually going to burn a little bit of CPU. Like if you have a large project and you let it infer everything, it's going to like take a while to infer everything. So we try to help it out by actually putting the return types on public methods and so on. And yeah, just dock the stuff and TS-lint it. Yeah, this is an example also that basically this is from my code. So this is supposed to say start marker ID, but in JavaScript, it's perfectly fine to say delete the key undefined, right? So I had a range, and then stat marker ID did not exist on this range, so this would evaluate to undefined. And then the code would just say delete object of undefined, and that's perfectly fine. As far as JavaScript is concerned, that's perfectly fine. And this was causing like quite a memory leak, because every time you would type, I would like make a little marker to remember something. I don't exactly know what, but every time you type, I would have one of these guys leaking, right? And I had no clue about it until I converted my code. Another thing which I found interesting is that what you can do with TypeScript is you can basically compile. So imagine now you're two teams, or maybe you're two different projects. So for example, we consume from the TypeScript guys, we consume this TypeScript services.js that they produce. That's just like a big fat JavaScript file, and you can throw to it TypeScript, you can throw to it JavaScript, and it will just tell you all sorts of goodness about it. That's basically how the demos I showed before in the editor work. We more or less take the buffer that you're typing, throw it inside this smartness. They're really smart guys, they know what they're doing, and they just come back and offer suggestions. They offer hovers and so on based on it. And we do that by them basically shipping to us a bundled, minified JavaScript file accompanied by a DTS, which more or less describes what is inside that JavaScript. And conceptually, this DTS, that's the API that we between our projects have. So if they make up a new version, we will get both new files, and we will just compile against the new DTS, and we'll just get errors wherever they have decided to drop a certain method or to rename it or so on. We do the same when we ship the Monaco editor, this thing that is a library and runs in the browser. And we also do the same when, whenever you're an extension, you get a vscode.d.ts that describes to you the API of VS Code on top of which you could build. There's something also cool that TypeScript supports. They're called decorators. In this case, they're constructor decorators. And we use them to actually get really nice service injection. So what they do in this case, this is basically an action in the editor. It's the action that if you press F12, at one point it asks someone smarter than it, and after the promise returns, it can actually jump to the definition of a certain symbol. So you would do this on a function. It would jump you to the place where the function is implemented. And then we actually use these decorators to signalize that we should inject some services to this action. In this case, I will just focus on the message service. So later in this code, it did not all fit in here. This action, if something bad happens, like a boo-boo, like a error, it actually calls inside this message service and says show error. Now, what this means is when you run VS Code, we have an implementation of the message service that shows a little drop down at the top, right? So here, imagine I was writing my cool Fibonacci code, and then I was saying go to definition. It didn't work. It always works, but this was just fake. And then it would just show a message at the top. Now, the same code that I've shown, which is this go to definition action, is also shipping with the Monaco editor, which is a library that runs in a browser, right? All of a sudden here, we do not own the UI. We do not own the exterior of the editor. So we don't know how this message should be shown in the app. So the default implementation we ship with of the message service is just a stupid console log. But of course, we have ways for people that integrate us to substitute that implementation with their own. And finally, inside the tests, here I had to do a little bit of paint art to cut them out that they fit. We basically say, if the message service inside the tests ever gets to show an error message, let the tests fail. So, yeah. OK. To more recent times. So we are actually built on top of Electron, and I would like to show you a little bit. Have any of you heard before of Electron? OK, cool. Nice. So I hope you will not find it too boring then. But it's easy. OK, let me stop the other things. OK. So here I have a minimal Electron app. So what is Electron? Electron is basically a very nice marriage of Chromium and Node.js. And how they work is that you give them a script. In this case, it's this main.js. I will show you in a second. Oh, okay. Sorry about that. Hey, cool. Okay. Sorry about that. So this is main.js. This is basically where the I define the entry point to this example. This is a minimal Electron example. So what it does is it uses their API, which comes in form of this module called Electron. And then once the app is ready, so usually you would say document on ready, but in this case it's more complicated, right? It basically creates a new browser window. It says that's your width, that's your height. And in this browser window, it will load the file index.html. And then once it's closed, it's closed. And once it's closed, it quits or something like that. So that's how you should read that. Inside the index.html, that's where you actually have, that's where you finally get both the browser API and the Node API. This main.js is basically a driver of these windows. So you know how Chrome, if you launch Chrome and you open a new tab, they make a new process, and you open a new tab, they make a new process. So how this all works is that they have a main process, which is basically an Electron driven by this main.js, and that process is always there, and that's the process that communicates to the OS. And that's the process that owns like the buttons, the menus, and so on. And then you have each render process, which is more or less what it gets rendered inside a document. So let me just try to run it. I will even show you here. Hopefully that works. So this is a really simple example. It just says hello world. But I wanted to show that already when I launch it, right, there's a main process, and then, and this you can recognize like it has, okay, it's hard to read, sorry about that. It basically says main.js. And then this one is a renderer process, which is the marriage of the HTML and Node. Now, to better prove that this is really a marriage made in heaven, inside this renderer.js, I have let some code in. And I hope your eyes are not bleeding right now, because, yeah, on this line, we're actually making a DOM element. And on the next line, we're using Node API to fill that element in. Right, so you should never do this at home, but that's actually one of the cool stuff. Oh, did I kill it? Of Electron. So now this thing runs and it just prints its own source code. But this just shows how you can, how they allow you to work together and have something which is both HTML and Node.js. So this is great if you're like, if you know JavaScript, you know HTML5, you know Node. All of a sudden you can build a rich app and ship it very easily. One thing I wanted to point out is that this main.js is a very important process. So inside this main.js, you should not do what I'm about to do now, which is more or less, it's a set interval, and what it's doing is it's computing Fibonacci, which is always good to compute. Everybody loves that. And the number it's computing on grows, right? So this is more or less exponential in O, big O notation, and so on. So if you now run this, what will happen is, you see as I'm moving the mouse, at one point, you see how the thing, okay, it's hard to say. Maybe we already lost it. But at this point, the whole thing goes down because how Electron inherits the process architecture of Chromium. So this main process, if it's now super busy, it will basically bring down everything with it, because even a mouse move actually goes to the main process, and then the mouse move is sent over to the renderer process, where you actually get a chance to do something. And if your main process is busy, your app is sort of dead. So this is just a little bit to motivate. Okay, thank you. I know I did this. I deserve. This is just a little bit to motivate what we do in Visual Studio Code. So, as I said before, this is basically what we get from Electron. Electron gets this from Chromium. And once you run it, you get a main process over here. And for each window you open, similar how in Chrome you open a new tab, you get a new render process. Now, what we've done is that, as I've shown you before, it's very dangerous to do actually anything in that one. Because if you by accident have something which is a little bit complex, or a little bit maybe takes 2 seconds, all of a sudden all your windows might not get the UI events and so on. So we actually create a new process that where we do things such as checking for updates, like, because this is something that impacts the entire product, or we do things such as managing extensions and so on. We have other processes, so for each render process we create an extension host. And we also launch on-demand processes, like if you do a search, we will launch a process, it will quickly search on the folder you have opened and give back the results and so on. We also have web workers. So this is all making the thing very complicated because each one of these processes, they have a different execution environment. So the blue ones are Node. The dark blue one is Node and a little bit of Electron. The purple one is Node and Electron and HTML5. The green one is just JavaScript and web worker API. So today we don't have a great solution for this, so it's still something we're trying to figure out. But we do use a folder path name-based convention sort of thing. So we have code under common, under node, under browser, and so on. Another quick demo, I will try to hurry up. This is basically how do we actually develop Visual Studio Code. So, okay, I hope you get to see it this time. Okay. So basically, to develop Visual Studio Code, you more or less clone the VS Code repo. You do npm install conceptually, and then just run gulp watch, which is just something I've already done before because I don't want you to be bored today. And one of the things we've invested in is that once you launch this gulp watch, it takes a little bit to warm up. So it's like takes maybe 30, 40 seconds. But then every little change you do becomes incremental. So if I do changes inside the VS Code TypeScript code, this guy to the bottom kicks in, and just like that, like in under a second or so, it basically has compiled and generated the JavaScript. This is something which we found very valuable, like this cycle of typing something and then being able to run it the next second is very important for us. So to actually run it, we just have in here a script /code. And then this runs Visual Studio Code in development mode, right? It runs out of the sources. It's not packaged, it's not bundled. It allows us to do nice debugging and so on. One of the things I wanted to do here is, and it's of course motivated by an interesting thing. So I don't know if you've seen this page. So at one point when I registered for the GOTO thing, they asked me to give a fun tagline about myself. So I thought, okay, what's cooler than drinking beer, which I love to drink, right? And apparently in the meantime, they renamed the field to say what company you work for. So that's why I'm the guy that says my job is to drink beer, which is a great job. So I thought then I just do a demo which actually shows I am a beer drinker professionally. So here I will just make a little change to some CSS, of course, and I will just do the right thing such that when you refresh, now all of a sudden you get beer in your editor background everywhere, right? So this is just the best. Who needs to read code? You could just say, oh, I could not read it because of the beer. So yeah, that's a tiny change. Something else which I wanted to show, and that's something we care and we do. So let me just bind these keys again. So this just adds some commands, which I have locally. We don't ship this because it's just some performance test. And now it's just bounce them to F2, F2, F3, F4. So what they do is they do lots of stuff like the F3. Okay, I have to refresh to get it, sorry. So if I now press F3, it's just a performance test that I run every now and then, which is just acting as if you would just hold down the cursor down and just like scroll down, right? And this is one of the things that we use to profile, and we try to really put an emphasis on making our editor performant. So let me remove a little bit the background. But basically what we do, and this is the one I actually like the most, is the F4 one, and I hope Eric gets to see that. So this is me usually working, right? So you see my productivity going up like crazy. But this is just a test, which is more or less typing out an entire file. And usually how I run this, of course, is I open up developer tools and I profile it, and then I try to dig into what's happening. So that being said, this is actually something which I wanted to share. It might or might not help you in your day-to-day life. But I wanted to share this technique that we end up doing in the editor. So this is actually called virtual scrolling. And what I captured here is, on the one side, I'm scrolling inside the editor. And on the other side, I have shown the developer tools, the DOM nodes, right? And you see, okay, I try to do it very slowly, that as you scroll the lines down, the old lines go up, they get pushed, and then eventually removed. So you get to see that they get removed at the top. And new ones come in, and you see they have this nice animation which shows you which ones are fresh and so on. So this is all very good. This is, of course, something which we had. Of course, this doesn't really help you if you have a really, really long line, like the F12 guys asked us to fix. But it does have some interesting problems of its own. So maybe the guys in the first row can read it. Do you actually know what this is? This is jQuery, but it's not here because it's jQuery. This is jQuery Minified, right? So as I was saying, this is actually, if you show this to any guy who's written an editor, they will tell you to go out, please, because this is just the worst you could do, right? Because at one point, if you think about it, when we have to render this, and we render it as each text, each little different color text, we make a span out of it. So we do create a DOM node, and it's a span. And for example, jQuery min, in the first 42 lines, it generates, we need to render like 3,500 tokens. Meanwhile, a normal file, like this is jQuery non-minified, is only 280 tokens, because mostly they have a lot of comments, which I love, because they're all green. It means performance is great, so write comments in your code. But basically the problem we were having, and something which I was doing, is I was profiling this and trying to see how it goes. So even though the frame rate was up, the CPU time was quite high as well. And one thing I would recommend is to get to know the tools you have. So I don't know if you ever used this one, this enable pane flashing. This one gets to show to you what actually Chrome paints on each frame. And after enabling this, I could see that on each time you were scrolling, the Chrome would paint the whole thing. And one of the reasons it was doing that is because as part of scrolling, I was just moving the position of the DOM nodes, right? I was just saying position is now -5. Okay, we have to cut it short. Anyhow, we used, in the end, Translate 3D. Yeah, these are some links. And yeah, thank you for listening to me today. Yeah.